afternoon.
Yeah. Okay, I'm working with him, and a backend developer. And for some time now, I've been working with I'm using Python to build backend APIs, RESTful APIs, and it's really a pleasure to uh, use all the skills I've acquired so far to contribute back to the community. Okay, my voice is a little bit low. Is it better now?
Yeah, go ahead.
Okay, all right. So before I start anything, I'd love us to look at the curriculum. That's what will be the topics that we'll be looking at throughout the duration of not just this class, but this what I would call this semester or this version of KodeCamp. And I'll share my screen so that you can look at the slide as well. Hello, can you now hear me?
Yeah, I can hear you.
Okay, can you see my screen?
Not yet. It's still loading.
Okay, see loading.
Yeah, I think I can see your screen too. Maybe you guys have to check your network.
Okay, please check your network and let me know if you can see the screen. Uche, can you now see the screen?
Not yet. It's probably my network. Let me try to refresh it.
Okay, Mike, how about you? Please, you can respond in the chat. Okay, that's perfect. That's perfect. So in this course, this is a Python intermediate course, and in this course we are going to look at basically everything you need to um, actually call yourself a back-end developer. And since this is an intermediate course, it is my assumption that you have some knowledge of Python. At least you should know the basics of Python. Am I correct? Mike Anucci.
Yes, I know the basics. Yes.
Okay, that's good to know. So in uh, in the whole of this class, we are going to use Python to build APIs. I know you may not really understand what an API is, but as we progress through the class, you will basically understand everything, like everything you need to know. And the way I teach, actually, I want to handle this class in such a way that you get the feeling of how it is in the industry. What I mean is, you learn to by the end of the class, you should understand how to make research on your own, make findings on your own, study the documentation, because there's absolutely no way I'm going to be able to show you everything. That's the truth. So as we are going through the class, I will show you how to make research. Let's say if there's anything you don't know, how you can know where exactly you can access this information in the documentation. And we'll also learn how to make full use of Stack Overflow. I believe you know what Stack Overflow. Who here has used Stack Overflow before? Which?
Yes, sir. I've used it. Yes, it's a kind of
Okay.
online platform where you meet, where you see other people's code, other work they've done, reviews, and.
Okay. How about mine? Okay. Yeah. That's perfect. Stack Overflow is basically I don't even know how to put it, but Stack Overflow is like a godsend. That's the truth. Because in your developer journey, you'll be stuck for sure. There are times that you'll be stuck for sure. And in this class, there are some times that we are going to reference Stack Overflow as well. So I'm hoping that with this knowledge of looking for what you need at on Stack Overflow and the documentation, you should be able to pretty much resolve almost all the issues that you should come across in your journey as a back-end engineer. So now we are going to go through the course outline. So first and foremost, we are going to look at the overview of the web and the web request lifecycle and an introduction to REST. Uche, I believe you can now see my screen, right?
Actually, no. I'm trying to, I don't know if it's, let me just disconnect and come back. I can't see it yet. Let me do that.
Okay. Mike, how about you? Hello, Mike. Can you see my screen? Okay. Yeah, you can see the screen. That's perfect. That's beautiful. So I don't know. Maybe we are going to wait for 1 minute for Uche to come back, and if he doesn't come back within that period, within that time frame, we are going to proceed. Okay. He's back now. That's good. All right, Uche, can you now see it?
It's still loading. It's telling me I started sharing screen, but it's still loading.
Oh, yeah, there's no issue. There's no issue. Since I'll be reading everything over to you, I don't think you really have a lot of issues with it. So, like I mentioned earlier, the first thing we're going to look at is an overview of the web. Like, what is really the web? Like, what is the web? That's basically what that is. And we are going to differentiate it from the internet. You know, the web and the internet are not the same thing. They are two different things entirely. We are going to look at how they are actually different. And we are going to also look at the web request life cycle, the request that actually use your browser or your mobile app. How does it proceed to the server, and how does the server give back the response? So this is another thing we are going to look at. And we are also going to look at an introduction to REST. Then we'll explain the meaning of REST and how it works and everything about it. So all these will be covered in this first class. And this will be purely theory. We will not do any coding. There will be we'll not be writing any code. Then from next class, we are going to look at the actual programming, like the actual programming. So we'll look at asynchronous programming. You know, we have sync and async. So in that class, we'll differentiate between these two. We'll also look at why async is important and how you can leverage on the power of async. So why we're actually bringing async in here is because that is like the newer way of writing code. And from analytics and everything, we understand that asynchronous codes are usually more performant than synchronous code. And from next class, you actually see that in action. So when we are done with this asynchronous programming, we are going to look at OOP. And that OOP you are seeing on the screen actually means object-oriented programming. By then, we'll understand what object-oriented programming is, why it is important. And when we are done with this too, we are then going to look at Fast API core. Like this Fast API is a new framework that, a new Python framework that you can actually use to create backend applications, backend RESTful APIs. And why we actually looked at asynchronous programming and OOP is because you will need that knowledge to efficiently understand what is going on in Fast API. You know, in Python, we have different frameworks that can be used for creating APIs. We have Django, we have Tornado, there's Flask, and there's Fast API. Fast API is like the newest guy in the block. But Fast API makes full use of asynchronous programming. As a result, is a whole lot more performant than the likes of Django and Flask. So that's why we are going to use Fast API in this course. I'm going to teach you Fast API in this course. And later on, from everything you've learned in this class, with that knowledge that you've learned in this class, you'll be able to apply that knowledge and learn every other framework that you need to know. Like I like saying this to my students. The most important thing about let's say back-end development with Python or any other language, it's not really about the framework. The framework is not important. And how APIs work. It will be very easy for you to move from frameworks like Fast API to other frameworks like Django, Tornado, and anyone that may come out in the future. I believe you are following me. Uche, can you hear me?
Yes, sir. Yes, sir, I can hear you.
Okay. Abayomi Abiodun, you just joined. I believe you understood what I said, right? Hello, Abayomi. Okay. So when we are done with the basics of Fast API, we are going to build a new project.
Good afternoon.
And is that Abayomi? Good afternoon. It's good to have you. Okay, so when we are done with the basics of Fast API, we are going to use this knowledge that we've gained to actually build a real life project. And I proposed building a kind of a minified Twitter. I believe you all know Twitter, right? Okay.
Yes, sir, I do.
Okay, Mike. Okay. Bayomi, how about you? Okay, I believe he too has. So Twitter is a very popular social network that you can leverage on to communicate with others, like to communicate with your followers and the rest of that. So we are going to build something very similar to that. It will not be a full-scale Twitter, but it's something that will mimic Twitter. So it will have the functionality for users to create accounts, like you register with Twitter. Yeah, you can register there. Then you can log in. You have a profile where you can make changes to your profile, like change the name and the rest of that. And a very important requirement is actually making tweets, like making tweets. So we'll add the functionality for that too. Then we'll also add the functionality that will enable users to actually follow and unfollow. We'll also add functionality that will enable users to like a tweet, unlike a tweet, and maybe we'll add share. That's if we have enough time, we'll add the functionality that should let a user share a tweet. And after that, we'll go to more advanced sections where we work on caching. By then, I'll explain more what caching means. I'll explain more what caching means, but the basic principle of caching is that it's much faster. Let's say instead of retrieving our tweets from the hard disk, that's from the storage, it's a little bit slower. We can maybe when someone submits a tweet, we can store it to a cache, an in-memory database. That's a database that is within your RAM, which is a whole lot faster than your hard disk, than your hard drive. So we'll look at how to work with that. And when we're done with that, we'll also deploy this mini Twitter application to AWS. I believe you've heard AWS before. It's a powerful infrastructure that is normally used to deploy applications like RESTful APIs, like websites, and so on and so forth. So when we are done with that, you will then have the opportunity to think of an application on your own and build it out, like build everything, deploy it, and you'll be graded based on that. So I believe you understand me. What do you think about that?
Yes, I'm I understand totally. I'm very okay. AWS, like my understanding, like a kind of cloud service, just like Microsoft has Azure. So
Yeah.
so I understand.
Yeah. It's a beautiful thing. AWS skill is a skill that is highly sought after in the industry. As a backend developer, you should be able to work with servers, not just the code. You should be able to work with servers and handle deployments, work with CI and CD, handle security, SSL, and the rest of that. So we are going to look at all of that in the deployment section of the course. So that is that. Now we are going to go to the first topic that we are supposed to look at in this lecture, and it is an overview of the web and web request lifecycle. Then we are also going to look at an introduction to REST. So I believe we all know what the web is. Like, the web is it's something that I believe we should like have an idea of. So, Uche, like, what do you really understand? When you hear the word web, like, what do you really understand by that?
Okay. The web, like it's a kind of network. It's a kind of very large network of let's say multiple networks connected to each other, where one can access information through different routes. So if we speak strictly, let's say from a website, we access the web through let's say a browser, and we connect through different websites. So let's say data is stored on a server. Let's say one, you have information, picture, video, image, text stored on a server, and one has to access that server. So you go through a browser, you make a request. There's different protocols through getting the domain name. There's it's linked to the server. You make a request, you get the information you want. It's displayed on your browser. So the web is just a very large connection of different networks. Let me just summarize it like that.
Oh, that's beautiful. That's beautiful. So, Bayomi, we were speaking about the web. I believe you've encountered that term before. So what do you really understand about the web? Like, I'm not looking for an official definition, but like from what you think, what do you think it is about you? Bayomi, are you there? Okay, Mike, the web is the internet consisting of different pages. Yeah, you have a point, you have a point. That's great. So we are going to actually look at what the web is and the okay, maybe first I'll first explain the web. And when I'm done with that, we'll look at what the internet is and work towards differentiating the two. The internet and the web are actually two different things. They are not the same. Right? They are not the same. Now, when we talk about the web, you would not be mistaken to think about the like the websites that you visit. For example, this Zoom website, it's something that is on the web. It is a resource that is on the web. And the web has several other applications like news, blog, and the rest of that. These are resources that are interconnected together. You could look at it as a collection of pages, a collection of pages. And please take note, they are a collection of pages, they are a collection of resources that are interlinked together, and they sit on top of the internet. Please, they are different things. The internet is the internet. The internet. How do I even put it? It's computers, a network of computers that are connected together. For example, like my computer now. If I have so many computers connected together and sharing information together. They may as well be considered as the internet. So there are so many applications of the internet. We can use it to handle email communications. It's also used to handle so many things like file transfer, etc., etc. And the web is just one of the applications of this internet. It's just one of the things that the internet is used for. So basically, how the whole thing works is that we do have central computers that can as well be called servers. All right. So anyone that needs maybe a website or that needs to host an application can go over there and rent a server, and from there deploy his or application to the server. That in that way, this server will be accessible to other people from across the world. A good example of this is the AWS that we spoke about. All right, these are a series of computers that we can rent, and we are going to rent later on in the course. After we finished building our API, we are going to rent this server and upload our API here so that anyone, anywhere can actually interact with this API. So I hope do you get an idea of what I'm trying to explain, Uche? And Mike?
Yes, I do. Yes, sir. At least from what I understand, my at least from my previous understanding of an API, just is almost like maybe like a script you write where it can go online and fetch data from different websites depending on how it is programmed. So maybe you want to analyze some data or you want to display some kind of data on your own website. So I understand.
Yeah, that's perfect. That's just one of the applications of these APIs. So that's that for internet and the web. And now we spoke about um, these servers sitting on one of these computers that makes the internet, and we spoke about users accessing the results. Now, how does this happen? That brings us to the web request life cycle. What you see, we'll look at it from the context of the browser because it will be easier for you to understand. Later on in the course, you will look at, we'll use the word client, like to encompass the software that requests for data from this server. For now, just replace this client. The client you are seeing here, you can very well replace it with browser. All right. So we are going to now look at like how does the browser actually get this information from a website? For example, what you are seeing on this page, like how does it happen? So this is what we call the web requests life cycle. I believe in biology, when we were in secondary school, we were taught life cycle of plants, life cycle of animals, how something is born and it grew up to adulthood and over time died. That was life cycle of plants and animals. And in this case, we are looking at life cycle of a web request, how this web request is born, how it gets from your browser to the server, how the server interprets this request and acts on it and sends back a response. That's basically what a request lifecycle means. So the first thing that happens in a request lifecycle is that, okay, are you following me actually? Hope you're following me. Okay, Uche, how about you? Hello, Uche. Okay, let's proceed. All right, so the first thing that happens is, let's say you go to your website and type in something. All right, you type in a URL like zoom.com. All right, a URL like zoom.com. Actually, when you type that URL on the browser, your browser will open the Zoom website. But before your browser actually does that, there are so many things that goes on under the hood. All right. The first thing that goes on under the hood is that the computers, these servers, don't you don't actually, the browser does not send requests using this URL. All right, the URL like www.zoom.com. The server does not understand that. The server is not working with that. All right, the server has an address on the internet, and this address is called IP address. And this IP address means Internet Protocol address. All right, this is the address that each server has. For example, it's like you renting a house somewhere, and the house that you rent has an address. For example, let's assume that my address is number 37 Back Road, Uyo. No, that's an address. All right. So each server that is rented on the internet has an address, and it is with this address that you can communicate with it. Just like your address at home. You know, if you're at home, no one can actually come to you without knowing the address, right? Uche?
Yes, and
You
no
agree
one
with
can
me?
come. Yes, you need to know the address. Yes.
Okay. And Mike, how about you? Is that true? Okay, that's perfect. Yes, no one can actually come to your house without knowing the address. So it's the same thing. A browser cannot send a request to the server without actually knowing the address of the server. And these addresses they are not readable. Like they are a series of numbers and letters. Like normally you would not be able to remember these addresses, these IP addresses. So that is where the URL comes in. That is where the URL comes in. So in this case, we have something like zoom.com. That one is easy to remember. You can very easily type zoom.com into the browser. All right. But it will be very difficult for you to, okay, I think let me show you that. Okay, I hope you can still see my screen. Hello?
I
can't see your screen.
And I think we are like two now that can't see the screen, so I don't know what is going on. Oh no, let me see.
Okay. Can you not see?
See from here.
Mike, can you see the screen? Hey, Mike, please mute yourself. Use the chat instead.
Yeah, I can actually see your screen, so I think you guys need to check your network.
Okay, it's okay. So I wanted to show you what the IP address normally looks like. So if you go to your browser's developer.
Sorry, Etienne. Okay.
Yeah.
So what I can actually see is the Python Intermediate General Course outline. That's what I'm seeing.
Okay, that's what you're saying.
Okay.
All right. Okay, please wait a minute. Let me share my entire screen.
Now I can see the screen.
Okay, you can see it now, right?
Yes, sir. Yes, sir.
I can see it too.
Okay. Okay, that's all right. That's perfect. So I want to show you what the IP address looks like. So first, let us go to a popular website. I believe you all know bbc.com, right?
Yes, I do.
Okay, so we are going to open bbc.com. Like normally you can, bbc.com is very easy to remember. It's easy to recall, right? But this is actually not the address that the browser actually works with. So if you want to see what the IP address looks like, you go to your browser developer tools. So you can click on developer tools. Okay, can you see my developer tool?
Yes, I can.
Okay, so then we are going to reload this page. All right, you can see this request going on here, right?
Yes.
All right, so when it's done requesting, we'll scroll up. So can you see this www.bbc.com?
Yes. It will start to
Yeah,
say open.
we are going to click on it. All right, so when you come down, you see this remote address. Can you see this remote address?
Yes, 151.181.36.
Yes, perfect. That is the actual address that the browser is working with, not the bbc.com. The server is not bbc.com. So what happens here is that when the browser gets this URL, the browser goes through a DNS search. There's what we call DNS, domain name system. So this domain name system is a register. I think a register. You know what a register is, right? So this register um, contains a list of domain names and their IP addresses. It's just like a normal register in school in which we have your name and maybe where you are from, maybe where you are staying. It's something like that. This DNS is something like that. You can read it up at your spare time. So this DNS contains a register of URLs and IP addresses. So in the case of this bbc.com, the browser then goes to this DNS and makes a lookup for a website, a URL called bbc.com. And from there, it will then extract this IP address and make requests to this IP address. So that is the very first step of the web request lifecycle. Do you get that step?
Yeah, yes, I do.
Okay. So after it translates the URL to an IP address, it opens a connection to the IP address. It actually opens a connection. It's like opening your door. Maybe someone is coming to see you. The person opens the door. Then after opening this connection, it actually requests. Let's not use the word request because it will be more confusing. It asks for a resource. It asks for something. Let's say your neighbor is coming to your room and the neighbor knocks on your door and opens the door and asks you, "Hey, um, please, Uche, do you have something? Maybe do you have a laptop for me? I want to use it for something." The neighbor is asking for something. That's exactly what is happening here. The web browser opens a connection to the IP address and then requests for a resource. And that is the second step of the web request lifecycle. Now, when this browser makes this request for a resource, the server actually will then interpret this request. Study this request. What is this client looking for? What is this browser looking for? And it then processes the information and returns a response to the client, just like you would process the information. Maybe let's assume your neighbor is asking for something. You process the information, get the thing, and return a response. So that's just basically what happens here. That's the third step. And the fourth and final step is that after the server has returned the response, the client gets this response and translates this response. You know, Actually, for a normal website, you can see my screen, right?
Yes, I can. Yes.
Yes. Okay, so for a normal website like bbc.com, what you are seeing here is not what is on the server actually. The languages, the like standards, there are languages, there are codes that are returned. It is the job of the browser to understand this language, compile this language, or translate this language to something that you as a user can understand. So to look at that, you can right click on you can right click, then go to view page source. Can you see this? View page source. So if
Yes.
you click on it, yeah, this is Can you see this gibberish? Like,
Yes, that's the HTML code.
yes. This normally, let's say if you were given something like this to look at, no one will be happy looking at this. To be frank, like if I go to the website and see this, I'll just bounce off immediately. So this is what is returned to the browser actually, and the browser has a major job of converting what you see here, this you can call it nonsense that you see here, to something more reasonable that you can understand. All right. So that is actually the last stage of the web request lifecycle. So let me recap. The first stage is that the client in this case can be your web browser, it can be your mobile app request client, it can be your normal desktop app request clients like Postman. We are going to use a lot of that, like Postman and Insomnia, etc. So this client gets a URL, converts this URL to an IP address using what we call a domain name system, or DNS for short. Then after it has done this, it then opens a connection with the IP address and requests for a resource. Then the IP address will then process this request and then return a response. Now, when this response is returned to the client will get the response, translate the response, and do something useful with it. So that's the summary of all the English we've been speaking here. So do you have any question? Let's start with Mike. Okay, Uche, I hope you understand.
Yes, sir, I do understand. Yes, just
Okay.
like you said.
There,
Yes, I do understand.
okay, Dell and Nate, you've not said anything in this class. I would love to hear your opinion on that.
Okay, I'm sorry, I just joined a few minutes ago, but I think I understand.
Okay.
Yeah.
All right. That is perfect. So let's go to the next subtopic. We are going to look at REST. Like REST. What is REST? Like, I believe you've been hearing something like that. RESTful, like REST API, RESTful API. What's really REST? That's what we are going to look at. So in the previous slide, we spoke about the client at number 2, at the second stage of the request lifecycle. We spoke about the client opening a connection to an IP address and requesting for a resource. Like requesting for a resource. How does it do that? So that's what we want to look at in REST. So REST is just a style, is just a standard that enables computers communicate on the web. Do you get me? It's just a standard. It's just a style, a communication style. Let's say something like English or French. It's a communication style that I don't think English or French would be the right word for it. You know, different people speak differently. Right? Like the way I'm speaking now is different from the way someone like Uche or someone like Nate speak, the terms used and the rest of that. So this REST it's just a standard that makes it easier for different systems to communicate together, you know, so that every single system, like the client and the server that we've been talking about, they know exactly how each other would communicate. The client knows the kind of request that the server would understand and respond to, and all of that. So that's just the basic English of the whole thing. So REST compliant systems, that make use of these REST standards, are called RESTful systems. And they are characterized by how they are stateless and separate the concerns of client and server. I've brought in some difficult grammar here. Grammar like stateless. Stateless. We've not spoken about this before, but we've spoken about clients and server. So I believe you understand that. But stateless, what is stateless? We are going to understand that as we go along. So in summary of the whole grammar, REST is just a style of communication. that enables computers, different computers, to communicate over the web. So that's just it. Then in a REST architecture, like we had mentioned earlier, clients send requests to the server, maybe to do something like retrieve, modify, or delete resources, and the server sends response to this request. So that's basically how the REST architecture works. The client and the server are two separate entities, or let's say in situations in which we have, um, for example, something like Facebook. In Facebook, we have a mobile app, then we have a website, right? Then we have the server. So this REST architecture makes it possible for the mobile app to communicate with the server and the website to also communicate with the server. So that's basically how this communication works. The clients, which is the mobile app or the website, send requests to the server, and the server processes this request and returns information. So for now, it's just grammar. You won't really understand what this means until we start working with the fast API. Then it will be very, very easy for you to understand. So I think let me pause there for so that everyone will be carried along. So Uche, do you have any questions so far?
Okay, and no, actually, I think so far I understand. Before now, I didn't know because just like you said, I've been hearing RESTful API. I even thought it was just maybe a Python specific term, but I found out that it applies to different language. So I understood everything you have said, sir.
Yeah, that's beautiful. When we talk about REST APIs, it's not constrained to just Python, all right, or to a specific language. Like you can build APIs with almost all the languages. Things like JavaScript. You can build APIs with JavaScript. We have Node.js, which is a runtime environment for JavaScript, like an environment that enables you to run JavaScript code on the server. All right. We also have things like Axum Web for languages like Rust. We have frameworks too for languages like C++, and you can also write APIs with C. So APIs are not limited to a specific language. Every language can do it. So REST is a general thing that encompasses everything. So with that, let's move to the anatomy of request. We spoke about sending a request. Like, what does this request contain? Right? What does this request contain? So the REST style specifies what a request should contain. So a request generally consists of number one, an HTTP verb. So we will, in the next slide, we will really look at all the HTTP verbs that are available. But for now, let us look at this BBC website again. Let's use that to analyze the anatomy of a web request. So as usual, if you go to your developer console, then you navigate to this network tab. Then reload the page again. Some requests will be made. You scroll back up to the root of the website. All right. So can you see this general tab?
Yes, I can.
Okay. So this general tab contains some information. All right. The most important one that we need is this request method. What do you see here?
Get.
Yes, get. So get is one of the HTTP verbs. All right. So each request should have that HTTP verb, and we classify requests based on the HTTP verb. For example, in the case of this BBC, what BBC did in this case was a GET request. It sent a GET request to the server. for this information that we are seeing on the browser. So that's the first thing that should be present in a web request. Then after that, we have a header, and this header can be used to maybe provide any information that you need, that the server needs. And the widest application is usually authentication. For example, there are some resources on the server that the user needs to be authenticated before the user can access them. So this authentication information is usually relayed through, it's usually added to the request header. So when the server gets it, it will then pass the header, get this information, and work with it. Let me check this BBC if there is a header. Any request header? Okay, this is it. So for this particular page, this is the request header. It contains the authority, path, scheme, accept. What kind of data does it accept about? Is text or HTML? Yeah, that makes sense. Then some other information which doesn't really matter to us at this point, like accept encoding, language, cookies, and the rest of that. So that's all that. That's just that for request headers. They are used to pass additional information that the server needs to actually process the request. Then after the request header, we have a path to the resource. I don't think okay, yeah, there's a path here as well. The path to the resource. So when we say a path, actually, the server contains a lot of resources. Take Facebook for an example. We have the home page in which you get posts. Those posts are resources, all right? Then we have the follower page in which you get your followers, people that are following you, or your friends. That's a resource on its own. So the page that contains those resources can be described as a path to the resource. Do you understand me? Hello, are you there? Mike?
Yeah, I can hear you.
Okay, all right. So the path is just, let's just say you are walking home. The path to your home, right, is just a route to wherever you are going. And in the case of this anatomy of request, the path to a resource is just the route to that resource. All right. There are some resources that are in the home. Take your room, for example. There are some resources that are, maybe let's assume whenever you open your door and get to your house, the home can be like your parlor, all right, because that's the first place you go to. There are some resources that are in the parlor, right, like the TV, the chairs, and the rest of that. So that's the home resource. Then there are some resources that are in the kitchen. There are some resources that are in the room, and the rest of that. So this path to the resource is like the route that you took from when you entered your house to places like the room, places like the kitchen, etc., etc. Please, is there any question concerning that?
Okay, no, it's fine by me. I understand.
All right. So in the case of this BBC website, in the case of this BBC website, this is the homepage, all right? And as a result, the path is just a single slash, all right? The path is just a single slash. Then let us go to another page. Let's check if it applies to this BBC website. Okay, we have, I believe you can still see my screen, right?
Yes, I can.
Yeah.
Okay. So I don't know if this is applicable here, but let's check. Okay, the request is done. Let us check here. All right. It sends a GET request and returns the 200 response. We'll learn more about this when we get to the coding part of the class. Now let's scroll to the part if there's anything there. Yes. Can you see this? What I've just highlighted.
Yes, that's sports/football/ some numbers.
Yes. So this is the path that this website took to retrieve this information. That's what we mean by the path. How this like just the route that our client took to actually get this specific information. So that's what we mean by the path. Then the last part of a request is what we call the request body. And in the case of BBC, it will not contain a request body because it is a GET request. Why I'm saying so is because this request, when we get to the anatomy of when we get to the different HTTP verbs, you really understand. This GET, it's like you are getting something from someone. All right, you are just getting something from someone. You are not giving anything back in return. All right, I'm just getting something from you. Maybe I'm getting a pen from Uche, or I'm getting a pen from Dell, or I'm getting a book from Mike. All right. So a body actually contains data. All right. Since I'm not sending any data, I'm not giving anything in return. So there's no need for me to contain a body. Okay. That is why this BC page does not have a request body. So if we want to send a data to the server that will be acted upon by the server, what we use is the request body. A perfect example is registration. I believe you've registered on the site before, like Zoom. Maybe when you are creating an account on Zoom, you go to the registration page, you then enter your information like the first name, the last name, the email, the password, blah, 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 anything you want to enter, all right? And then click register. What the website does is that this website will package all this information that you've entered. We'll see it live when we start the actual coding. So the website will package this information, all right? It will collect that name that you submitted on the form. It will collect that email. It will collect the password, the username, any information entered there. It will then package this data, and this data will be part of the request body, right? And then send this data to the server. Then on the server will then pass this data, get this data, extract this data, and work with it. So to recap everything, an HTTP request is basically made up of 4 parts. All right, we have the verb, which is something like we had explained before. The HTTP verbs can be the GET request, like we saw in BBC. Then we have the POST, we have the PUT, we have the DELETE. All right, it contains that verb. That verb has to be there. Then after that verb, we have a header that contains some additional information like authentication information and any other information that you'd like the server to know. And this HTTP request also contains a battery resource, like what are you looking for, what do you want to act on. So how does the server get this resource? That is the information that will be the path. And finally, last and not the least, we have the request body that contains the data that you want the server to act on. And I gave an example like registration, user registration. The data you enter into your website is then packaged, processed, added to the request body, and sent over to the server. Is there any question? Uche. So
Yes,
can you
sir.
please recap, like, what we...
Okay. Just like you said, you just gave like a brief breakdown of what goes on when you like type a URL on a browser. So there's you mentioned a verb, what is called the verb. So the kind of request that is made. And you gave an example of the get request there, which we saw. So we just get information, and it's just like a one-way communication. We are not sending anything. We are just trying to receive information. Then you talk about you mentioned some other things, and like the status code or something. So that one got completed with 200. And I've personally made research on, that, I know that 200 means good. I know there's other codes like 401, 407, something like that. Then you talk about the
that's
body.
perfect.
Yes, talk about the
That's
body.
perfect. That's perfect.
So, that just which is not relevant now because of we are not sending anything. We are not like giving. We are just receiving. We are just requesting. So just but I understood everything you said.
Yeah, that's wonderful. That's wonderful. Dale, how about you? Dale, are you there? Okay, are you Miss Cool? Okay, so I believe you all understand. Now let's move to the last thing we are going to look at today. And we've been speaking about the HTTP verbs like get, post, like what are they? All right. Now we saw get on this BBC website. All right. So what does it really mean? So that is one of the things that has to be included in a request that is sent to the server. All right. Now we are going to look at the different types of HTTP verbs. There are four. There are four major types, but there are more than these four. But in this class, in this course, we are going to look at the four. All right. The first one is get, and a get request is used when you are requesting for something from the server, right? Like in this BBC website, the client is requesting for something from the server. It's requesting for this information from the server. All right. That's why it is using a get request. You use a get request to request for a resource on the server. Let's say if I'm coming to Uche's house to ask for something, all right, maybe to ask for a laptop, I would use a get request because I'm asking for something. Do you understand me? Uche, do you understand me? Mike, are you there? Okay.
I'm with you, I understand.
So,
thank you.
All right. So we use a get request to request for something from the server, just like get. Get in English means to collect something. Okay, so when we want to collect, we use that get request. Then we have another type of request that is called a post request. And I believe you know the word posts. Like, let's say in the era of writing letters, right, you write a letter and then post the letter to someone. Okay, so post means to actually send something. Maybe I'm posting my laptop to my cousin, right? I'm sending something over. All right. So when you're sending something to a server, you use post most of the time. We will explain more. Why I'm saying most of the time is because you only use post when you are creating a new resource. When you are creating a new resource, for example, I want to create a new user on my server. All right. I'll use post. So you send this data with a post request. The server will then understand, okay, this is a post request. This guy wants to create this data on the server. So the server will then create the data and return the response. So that's that for post. Then we have put request. Put means to update something. All right. It means to update a resource. Let's say I already had a user registered on my website. Let's assume I am Mark Zuckerberg, of course. Because I'm not to change your password, or you want to change your name, or you want to change anything. All right. That request that you are sending to the server, will be a put request, because you already have that information there, but you want to change something, you want to update something. So that's that for put. And finally, we have a delete request. Like the name suggests, delete means to remove something. Okay, let's say my website is Facebook and a user wants to maybe delete a post or delete a comment or delete a message. All right, you send a delete request along with an identifier for this information or this resource you want to delete. So when this information gets to the server, when this request gets to the server will then pass, process, check that, okay, this user has the right to delete this resource, and finally delete that resource. So that's the basic overview of this get, push, put, and delete. In the next couple of classes, we are going to go into, we are going to actually write the code whereby we will see this in action. For now, it's just grammar. It's just grammar. It's difficult to understand, but when we start writing code, it will be much more clearer. You see how it works, how this get request works, the post request that's creating a new resource, the put request that's updating a resource, and the delete request, which is used to remove a particular resource. That was a long class. Please, do you have any question? Mike, do you understand the HTTP verbs? Del Ayumasu Uche. Any question on that?
So I don't have a question, sir. I perfectly understand.
Okay.
Yes, sir. I perfectly understand everything. You explained it very well. Thank you very much.
Okay, that's good to know. That's good to know. So if at any point you should have any question, all right, you just need to search for me on Slack and send any question you have, and I'll be very happy to respond to it. All right, I'll be very happy to explain it again. Okay, so that's
okay. Hello. Sorry. Actually, I understand everything, but
okay.
I have a
That's
question.
Okay.
All right. Thanks. At least right now, I know. I have an idea already, but I understand perfectly. So the question I want to ask now: which framework are we using? Is it Fast API or Django REST framework?
Okay. That's a beautiful question. It's like you were not in the class at the beginning, so we spoke
Yes,
about.
I started it. I joined it.
Yeah. That's understood. It's okay. So we spoke about the frameworks earlier, and in this class, we are going to use Fast API. All right. Though the framework, like I've been saying, framework is not important. All right. As long as you know the language, as long as you have a strong understanding of the language, and you understand the basic concepts of HTTP and the rest, you can always, for example, in this class, we're going to teach Fast API, but you can always learn Django on your own and rebuild what we built with Fast API. You can perfectly do it with Django, and there will be no issues. Why we are using Fast API is that a Fast API it leverages the power of asynchronous programming. As a result, it's a little bit more performant. Like a lot of people can access your server. For example, if you have a server that maybe could have only powered something like 50,000 concurrent requests in a second with Django, something like Fast API can extend that bandwidth a little bit because it's using Async. Right? We'll learn more about Async as we go in the class. So apart from that, the framework doesn't really matter. We are just teaching Fast API, all right? But anything you can do with Fast API, you can do it with Django. You can do it with Flask. You can do it with Tornado. It doesn't really matter. So we are just teaching Fast API as an introduction to you. When you are done, I would recommend that you go and learn something else and add to that, like Django in your free time, and add to that. So that's that. Please, is there any other question? Okay, so with that, we come to the end of the class, and I wish to thank you so much for making out time to attend this class. And in the next class, we are going to look at an introduction to asynchronous programming. I've been talking about asynchronous programming here, so we are going to really see what asynchronous programming is, how it is used, the basic syntax of asynchronous programming. So, thank you. That's all.
Okay, so thank you very much, Yume. Okay, so everyone, if you have an issue, please just make sure you ask a question on the channel, on the Python track channel, okay, on the intermediate channel, and then you will get a swift response. Okay, so thank you very much and have a wonderful day.